looking at the new Octopart Discover tool, which is actually looking at doing some of the things you described, but I don't know the full capability set yet. So hopefully those guys over at on the Octopart team will respond to my invitation to come onto the podcast and discuss some of that stuff.
As you just saw, you're going to note, and anyone who follows me, I have a couple different names I use for things. You saw Altium Cruncher. The cruncher is my way of saying that's a utility that takes data and like grinds it up.
Right.
And I have monkeys. Monkeys go and get me things. Well, I just built Supply Chain Monkey is the thing that goes and gets me my stuff to feed into the cruncher that grinds it up.
Today, we're talking with Eli Hughes, principal at Wave Number LLC. If you are part of the PCB design community on LinkedIn, you have probably seen Eli posting some very cool projects for PCB file formats, and I'm very happy to talk to Eli today. Eli, thank you so much for being here.
Thank you. It's nice to be here.
Yeah, absolutely. So I'm glad we finally get to meet because I feel like I've been following you for quite a while, and I see a lot of the cool stuff you post. But before we get into some of the projects that you've worked on, if you could, since you're a new guest, give us an overview of your background, how you got started in electronics.
Yeah, it's like a lot of stories of I'll call it the irreproducible background of falling into something that I'd never expected. So I went to college for electronics, and I kind of fell into that initially because when I was growing up, I'm kind of like young Gen X, so like NES and Nintendo and Sega Genesis and 80s hairband rock was like the rage, right? And so I grew up in a small rural town, and you were kind of in the music and where you played Nintendo, right? That was it, right? And but I really got into video games because once I discovered like that Nintendo, the processor in it, I was reading like Nintendo Power was like the magazine at the time, and it mentioned like the 6502. And it just caught my eye because it was 7th grade. We were computer literacy where you had to like type in like programs like in BASIC, right? And just I got addicted. I was like, oh, I can draw a line. It doesn't look like the NES, but it's cool. Then I kind of realized it was the same chip, and then I just went deep. And but the problem with at the time we couldn't afford a computer at home, and then that was the only class. And then I just kind of went into music and almost failed high school because I played guitar and keyboard and bands, and that's all I cared about. But I went to college in electronics because in Pennsylvania there's a tech school that I went to go visit, and it was like the quintessential demo of I was looking around, but there was some kid in the electronics program. I wasn't even that interested because my dad did electronics, but he fixed old church organs, like old Hammond church organs, analog. I don't want anything to do with that. But I wasn't aware of what electronics could be. And the kid, as part of his project, at the time, I think it was like the Intel 286 or 386 was like the best thing. But what the electronics students did, they had an ISA card in the machine. It brought out a ribbon cable to a breadboard, right? And you actually like hooked up electronics to the bus. He had it wired up to some robot arm, and he was writing assembly code for a demo. And I connected. I'm like, wait a minute, I can write code, do some stuff here, and this arm moves. And at that point, it was electronics and embedded systems weren't even two things. It was like I was all in. So, I just got super motivated to do electronics, but I played a lot of guitar. So I went to build guitar effects. And at the time, the digital amp modelers were just starting to come out. And it was right at the end of my college career. So, and we had a course in DSP, and I'm like, that's what I want to build, right? And so that took me down another path. And I kind of took another road though. After that, I had a job doing R&D for Department of Defense for a local company, but I found a program at Penn State University, where I live now, in the science of sound and acoustics. And I always lead with, I went there for a master's because they let me in, right? Like they're the other ones that let me in. But it was just interesting because it was kind of a place for people with no other home, because it's electrical engineers, mechanical, physicists, biology. Everyone's kind of into music, but it's about the science and physics of everything that vibrates. And I had this dream. I wanted to like work for like Yamaha or someone, right? I wanted electronics. Well, that just got me in another world. I went deeper into Department of Defense, torpedoes, undersea weapons, robots, space, and kind of most of my career was that R&D, high reliability kind of stuff. Always done consulting. Took a break to do a startup, a few years ago. But now I say Wave Number is actually the LLC I put together for me to pay for grad school because I had kids. I do some consulting, so it was just a word in my homework assignment that I had at the time. And I said, that's it, right? And that's the company name. And, so now this is all I do. I just, kind of like a hobo, I find jobs where I can and have a team of ninjas and we do cool stuff. So, yeah, that's the background.
Yeah, I so identify with a lot of that, especially with like, with music, and then kind of seeing that first electronic device like do something when you put in some code, or even just seeing your computer do something interesting when you put in some code. For me, it was, I was in the third grade, and I don't know why the teacher's husband decided to take me and another student aside and start teaching us Quick Basic, but that's I guess what started it for me at age 8 or 9. So yeah, I so identify with a lot of that.
There's one other piece, and we'll tie in what we're talking today, because like I was still in like video games at the time, but I got really into not only playing them, but like there was a distinct point, and it was when the Super Nintendo was released, and they would always kind of have like the fold out page with like specs that I didn't understand anything about. But one of the cool things at the time, it had some hardware features to do like scaling and rotation of sprites. And that was a big deal, right, in hardware. And so my brain was like, how could that work, right? How in the world? And so through college too, I'd spend all my free time of it went from that into like 3D graphics. And the tie-in here is that the college I went to, which was rare and it's still rare, we had a course in PCB design, right? It was dedicated, and it was 1997, and we learned on Protel on Windows 3.1.1 with floppy disks. So, that's where like my Altium, history started then. But it was really cool because it was, you really got a sense early on of like the schematics and layout, and we etched PCBs, and the teacher took us to some contract manufacturers. We went to a PCB fab and just got to see the whole thing. And then I'm like, wait a minute, I can write the code, but now I can build the board. I'm not limited by stuff I can buy, right? I can build it. And that's what kind of linked in that throughout my career, I've always been software, but PCBs are like, it's another old standby. When I'm in a funk and I want to do something, I want to do a PCB because it's relaxing. And there's something about it that, and it started back then, so yeah. And a lot of people have that similar kind of like entry point where you just kind of get addicted because you make your own and you're like, wow, the world's my oyster here. So.
Yeah, it was like that for me with PCBs too, right? Once you kind of get into it, you get bit by the bug, and it's something you don't want to let go of. And it's I don't know, I think it's one of the reasons that I think people push back against AI a little bit, because they actually like doing PCBs.
Yeah, and I've thought a lot about that, and like it's really hard when you like introspect, you self-reflect of what actually do you like about it, like, because there's parts of it when you do it for a hobby, there's things you like. When you do it professionally, you realize there's a lot of aspects to it that you don't like, or they're necessary things that actually take up more time. Like a big topic is routing and AI routing, and like I think that's great and they'll probably solve it, but to me that's not even the part I want automated. It's front end requirements, and then documentation, dealing with CMs, bombs, like there's all this stuff that's like before you get anything on that PCB, you're worried about all this other stuff. By the time it gets to the route, yeah, I kind of just want to do that. Like, it's just, it's your thing. So
I 100% agree with that. Yeah, I think that the real opportunities are outside of just, place and route.
yeah,
And there's some stuff that, like, I get what you're saying, like with especially like with components. Like, I don't want to make footprints. I hate doing it, like, I don't know why we don't have that already figured out. That should have been the easy lift for AI.
Here, and here's the trigger warning for all the listeners that, and I do this, and some people get riled up when I say this, especially people are from a very classic PCB workflow. I say your library is the most useless thing you have. Like, it's the necessary but useless for one reason only. And I'll give you an example. Like, here's something our company's been working on. This is a Xilinx Zinc with DDR, a gigasample ADC. There's going to be 64 of these on a motherboard for a giant data acquisition system. So when you think about that Xilinx chip, all right, you might take the pin table and spend a couple hours making the symbol and footprint. The value isn't that. It's the weeks into the page of configuration and power management. Once that thing's in my library, I ain't using it from the library. I'm getting a schematic that I know works, right? And so, like, that's why I say, like, somewhat jokingly, that the library is kind of useless. I want the thing after that, right? That works. That's the thing I'm after. Like you said, same thing with the footprint. I'm like, it's certainly necessary, but I think probably in the next few years we're going to see maybe some other ways of doing it that might take a little bit for people to adopt, but are better just because we have the tech and the tools to, to help.
Well, maybe we'll have an agent that can, script out, running the IPC footprint generator in Altium really quick, and then you've just, bam, you've got all your footprints.
You say that, and what I'm going to show you today is going to maybe get you to think a little different.
Okay, I'm happy to see it, and that's actually a good segue into one of the reasons I wanted to have you on, which is you have been showing recently, and you have created over the years a lot of open source projects, and it's not just boards. I know you have like the Monkey mini board, I think it is. It's also software utilities for PCB design. So I'll let you run which direction you want to go first. But I'm really interested to talk about that.
Yeah, and I'll kind of lead into it. And so, like, with the open source, it's interesting. And this is like another sacred cow that, like, I have an article I haven't published, but like open source software, like I use a lot of it. I use a lot of proprietary, and I like, there's a whole ecosystem around that. Like, hardware is like a different animal to me because, like, opening up hardware, giving someone the schematics, even if you give them KiCad or Altium or Eagle files, I call that convenient. To me, that's not the part that's open. The part that I care about is, like with hardware, is I don't necessarily care about your schematic. I want to know, why does it work the way it does? And, I give people this story that when I was growing up, my dad had this magazine, Radio Electronic or Pop Electronics. And they had an article on how to build a wah-wah pedal. It's like a guitar effect that, Jimi Hendrix used it on Voodoo Child. It's like, if you hear it, you know what it is. Well, this was open source hardware before there was circuit board design software, but they didn't call it open source hardware. What they did in every one of those articles, they gave you the schematic diagram. They gave you like some bill of materials, like a wiring diagram. But the thing that made it open was the theory of operation, that they said a wah-wah pedal is just a tunable notch filter, right? That's what made it open, that you've now explained to someone, it is a circuit with this notch that you kind of modulate that center frequency. And anything that does that is a wah-wah pedal. And so, like, my philosophy is like, well, I'll certainly give out schematics. I want to explain, how does this thing work so someone else can build their own version of it, not mine. Like, and that's kind of a difference with software, is like a reusable component versus reusable knowledge. And so yeah, I spend a lot of time anymore, just if I would do something, write an article about why does something work the way it does. The monkey board, more of it, less about the hardware, more about what's the process of the layout and decoupling caps and, all the things you need to do to get it to manufactured. You might not even use the schematic or the layout. It's just now you've seen the process, and and that's kind of the genesis of a lot of that work. And so where it kind of grew into, and this was probably, I don't know, over the years I've used Altium forever, and I've used other tools just throughout my career. I'm kind of like a junkie that agnostic. I just want to make PCBs, right? And so I'll do whatever it takes. But I'm always thinking about, there's parts I like and parts I don't like. And, with my role now, efficiency is key, right? It's not only efficiency of executing the design, but when you go to order it, I could delegate that to someone. But if they spend 3 days asking me a bunch of questions about, it doesn't help me. So I'm always thinking about, how can I make the release package quicker? How can I do X, Y, or Z? And some of the demos I'm showing on LinkedIn started from one frustration. It was about 3 years ago. I was in Altium, and I was using like the bomb dog and the out jobs, which is kind of like the standard flow. For whatever reason, I pressed the button and it would just grind for like a minute, and I'd have to wait, and then it wasn't right, and you'd like fiddle with it, and it's like 3 hours later, I'm still like fiddling with it, and I need the bomb and all these formats, and I'm like, there's gotta be a better way. And then I just started thinking about the process, and well, why am I even doing it this way? Like, why don't I just have a utility that it just runs on the files and it generates everything I want in all the formats, and even to the point where all the manufacturer data, let me just go fetch that as I need it. And I just want it to be 2 seconds, not a minute. And that's where I came up. That's where all these Altium file parsing came from. I just wanted to make the bomb on my own with just standalone, because I immediately then wanted to run it on 100 designs. And from there I just kind of said, well, I got this far. Let me make a pick and place file. How do I have to pick apart the file? And then it just kept kind of expanding from there of kind of different stuff. So that's the genesis.
Yeah, so you mentioned a few things here, right? You mentioned the monkey board. That's one of your hardware projects. I remember first hearing about you from that particular project, and then you also mentioned like the parsers, right? Which I thought were pretty interesting. And then one thing you showed recently that I thought was pretty cool was a visualization tool for like a viewer.
Well, and I'll step you through, and I've got some of this kind of ready to go. So let me go share my screen, and
we'll include links to access this open source stuff in the video description on YouTube.
Yeah, so I just have a folder, and this is actually one of the Super Monkey boards. I always use it for a demo with just some Altium files. Is the tools as I've written, they're kind of like, they work reverse from like a normal out job. The idea is like, you have your files, and then you like run some external program like on the files. Kind of like the name, it's just a little command line utility. The one you probably saw, and this one takes a little while to run, is called 3D Viz. So, Altium Cruncher is just like a collection of tools, and we're going to step through a bunch of them. And this one wasn't the goal. It was something that came for free along the way, that once I started was able to like parse schematics and PCBs and yank out this data. There was kind of like another thing that I always wanted, was that a lot of times you might want to give a schematic to someone, or give like you give like a PCB or a PDF. You can do the 3D PDFs, which are okay, but I really wanted this to generate something that just makes a single file that requires nothing to install, nothing to add on, and it just works. And so the 3D Viz, I'll open that one up because it's the coolest. So it's literally just an HTML file. Everything is in that file. So you don't need a cloud connection or anything. And so this is Super Monkey Rev C. And so some of this, and the reason I mentioned the video game tie-in before is I was always super interested in 3D graphics in gaming. This is kind of like the expression of like, hey, I can do 3D graphics. So the reason I made this was for, not only to kind of look at it and to give it away, but for, some other practical reasons is, so a lot of times I or someone is doing like board bring up, and you might be at a bench with a tablet or a PC. You might not have your tool installed and you just need something quick. So I just want to go in here and, see, what is this net, and kind of get it to highlight, and then kind of pan through it and kind of find these things. But once you kind of all this data in there, there's just kind of cool things you can do. And so one of the things I always wanted was that all these tools have the, kind of, cool 3D views. You can like flip things around and I can see my glowing trace. But a lot of times I do like 2D, because here with this, trace, I can only see one at a time. I want to see it all at once. So I'll turn the components off. So I made this view. I just hit 2 and it just kind of blows the board apart. So I can kind of see simultaneously all layers together. And that way, as I'm tracing it out, I can see the red glowy, maybe turn into like black and white mode so I can really see it, maybe click on a power little VDD core power plane. And so some of this was just, I had the raw data. I like to play with 3D graphics. I want to make it anyway, right? And so let me keep hacking at it and, just see what kind of comes out of it. And so a lot of this is just like experimentation into like, here, I want to find C1, right? Of just having a tool that I might be at the bench or just hacking away trying to debug something. So I just had a system where I could kind of run experiments to find where the value is in like these visualizers. And so then every once in a while when I get something to work, I drop it on LinkedIn and just see what people say, right? Most of the time it's good. So yeah, and so this one was, pretty cool. The other one, which is almost, if I could get someone at Altium to like rewrite the code, I'd have them do it, is that the 3D side's always been good. I also made a schematic visualizer. So it works the same way, where it generates just an HTML file. So this is just, it could be in your Git repository or wherever, it has no dependencies. It yanks all this data out of the file, and you kind of do the same things you've always done, you maybe in Altium, but I wanted to start playing around with of like, what if I could have a fast zoom, right? Because this is a common thing. Well, a lot of designs, you'll see this pattern where you'll have like net labels on a net, and it ends up somewhere else. It's with a multi-page schematic, even if it's drawn nicely, it can be hard. So I said, you know what I want? I want to click on this thing. I want it to tell me and show this little diagram, and do this across multiple pages simultaneously. Because when you're in the mode of inspecting or finding things, it's different than I'm trying to draw the schematic. So I kind of use this as well as a way of saying, of prototyping, if we were to make changes to a schematic editor, what things have value? And I, of course, just do it for me of like, what things do I have value? What things do I want? And so every time, once again, I get it to work and I drop it on LinkedIn, right? It's even kind of cool if you hook up like a power net, it'll just kind of show you how it flows. And, for some of the more complicated ones through VDDIO, it just kind of gives you this drawing so you can kind of see this kind of animated view. And it's just enough visual cue that when you're looking at a new schematic that isn't yours, you can find things quicker. Do things like, bring up a little bomb to, find parts. So
that one point you just mentioned, right? If it's new to you, you can find things quicker. I think that's a really great value in this kind of view, just because, it always takes time to like read through things and kind of manually see what's going on in a schematic. And then like eventually you find out what to highlight and that kind of thing. But it's, I see a value in this and just kind of being able to click around and just see what's going on, right? Without any risk of like messing up the schematic in Altium Designer.
Because you think about, you have two modes, right? You're like design entry mode, you're in design, but once you like it's released, it's out there, then you're in board bring up mode, right? You're at the bench, you're like, and you want quick, lightweight, and I don't want to muck with the file. I need like a new view on it. The more schematic pages you have, the worse it is. And so, and a lot of times in this case, this is this showing on the Super Monkey, kind of like the IO connections. You go backwards, you're like, okay, I'm at the connector. I want to get back to the MCU pin. What one is that? Oh, I come back here, that's port IO2, right? You just can find it instantly. And that's that's kind of a lot of it, of not only for board bring up, but for the person writing the firmware, right? You might give your firmware developer a schematic. They've got to unwind all this because they want to know, all right, what pin on the chip and what port is it? And that's important to them.
That's another really good point for the firmware developer, because they typically don't have the ECAD license anyways. Being able to have the visual view of the actual PCB right alongside the schematics, that's really cool.
Now, all of this is downstream of, like, this is kind of like the pretty front end, but it was actually not the reason I made it. Like, all the data you need to drive this is kind of in those files or can be derived from them. On the software side, this is kind of the difference, and part of the place where like AI automation can really help, because like our team, we do a lot of firmware development as much as like hardware development. The AI tools, not even from a design review of just helping you, can't even have to, even as on an Altium file, scanning through PDFs is the source of a lot of error because it has to yank through things. So one of the commands that I added is, let me go find my terminal window here. And for someone, and this is going to show my age of like the generation I grew up in, let's say I have a design, I call it Altium Cruncher, and it's called Megamade. This is from...
I know the reference.
Yeah, from the movie Spaceballs. And it's going to do a bunch of things. So it's going to run for a minute. So this is kind of like every parser and every tool. The idea of Megamade, it goes to the PCB dock, the PRJ PCB, everything, sucks everything out in some raw form to be used by other tools. And it actually started out early on of like, sometimes someone gives me a PCB and I just want the libraries out of it, but I don't want to click an Altium. I got a bunch to do. I just want a really quick command. Or let me go in here. We'll go into the Megamade. So what Megamade does is it makes a schematic lib, both a combined one in every schematic symbol, like in that one command. The PCB lib, it creates a split version in the combined, so you suck out all of those. I pull out all the raw step models, because sometimes you get a footprint, you want the step model, and that's kind of hard to get out with another tool. So Megamade is kind of like that vacuum cleaner of just sucking it out. The one that's probably the most important, which was the hardest to get to work, was the netlist. And it's the one I use for software development almost daily. And so what this is, and I'll kind of collapse some of these, it pulls out the list of components as they are in Altium, the designator, value, footprint, and all of those parameters. So in some ways, it's the BOM, right? It's just a quick way of getting the BOM. The next thing it does is under nets, it just gives you this net list of every pin to every IC, the name, and the pin type. So from these, this is where you can figure out, all right, U1 pin 1 is connected to U3 pin 3. But the important part, that the format of this is JSON, it's text. AI loves this format. It can read through this and just grind through it. And so the other thing I do is I actually link it to all the power ports, all the unique IDs, the graphical entities, and then the most important part, sorry, the files get kind of big, so I got to collapse a bunch. This is where it took a little bit more time to write. Bridge components. This was the next part of the analysis of that. Humans' brains, one thing we can do pretty good is when you look at, say, like a net, let's say you have a microcontroller, it's like a port pin or maybe some sort of data transmit pin. It might not run to a connector. It might run to a connector through a 33 ohm resistor, like a series termination. So I also pull all of those components out to say, here's all the components that link to nets. So those two nets, while they might have different names, they're kind of the same one. And that way the AI can look through that and say, oh yeah, that is a series terminator, but let's treat that as like effectively the same signal you're looking at. And so when I do design reviews now, I literally open Codex or Claude. I say, run Altium Cruncher netlist. We have all the data sheets, but then I can say, hey, from what you can read in the data sheet, build me the power tree, because now it has all of the semantic information about, the pins, the functions, and everything. And it's scary good to tell you, saying, oh yeah, you've got your VDD core going here, but the NXP data sheet says, no. The reason I built this was to kind of deconstruct the schematics and PCBs into a form that's just enough for the AI to do a better job without having to look from an image. Because I think all the tools now that are trying to do it from image capture are just, it's just way too much work. But if you can just have some helper tools to pull out real semantic information, it looks at this and it is so crazy good. The last piece, and this is what might get like software or firmware developers excited, is all of these terminals and pin lists. Like, for example, I just pulled up U1 PIO 2.31. All right, this is a NXP chip RT685. I do a lot of work in the Zephyr RTOS. So Zephyr uses, a lot of Linux-like language like device tree, and it's always a pain to write those device tree documents for customizing your boards. I can literally in 2 minutes tell Claude, hey, use Altium Cruncher, grab the net list. We're going to make a custom board for the RT685. Not only that, look at all the peripherals they're connected to and build me the device tree. And I did this last week. It not only said, all right, it built the GPIO, but it figured out all my I2C connections. It could look at the chips for all the peripherals, figure out which ones had Zephyr drivers, and it created this board file. And I'm good enough with Zephyr. Before that, you would spend a day at a minimum for an expert. Now, when I say it's like 2 or 3 minutes, it's 2 or 3 minutes and Claude knows how to build it and is ready to go. Then all you have to do is do a quick scan of yeah, it's right. And it's kind of taken all of that effort out of BSP and board bring up. Mostly because the tool now has a way to look at your design in a text form, but there's just enough linking data that it's, the hallucinations and all that are almost, non-existent. This is the reason I built the tool. It wasn't, the visualizers were the, me having fun with 3D graphics, but, this was the thing I really wanted.
Well, you're already giving me some ideas. So, folks who may be listening and haven't subscribed to the channel, make sure to subscribe because we might show some interesting applications of this in some design videos in the near future. That was pretty cool, especially with MegaMade pulling out all of this information that's embedded in these files.
So, what's interesting, when I showed that the first time, people are like, cool. If someone says, well, don't you know, dummy, you can click in Altium and say export. I'm like, I do know, but what if you had 100 schematics for all your company? You're not going to, even if Altium is easier, the time it takes for Altium boot, run the out job, all that is just too long. But if you have a tool that maybe every time you check in and commit, it just generates this for your developers as automatic documentation. It's for doing it at scale. And the other piece of this, and it's a thing I haven't mentioned a lot on LinkedIn. I'm actually putting it together. I've been a little quiet because I'm pretty close to the first demo. It's tied to this whole idea of when I say the library is useless. I say that's so funny, but think about any company if you work for or yours. They might have a history of schematic designs that's 20 years. I know for me, I've been using Altium, I have ORCAD, I have all this stuff kind of loosely connected, but an LLM or even the best AI can't search that very well, right? But what if you had a tool that could go through your entire scattered company database and kind of restructure it as a knowledge space that you could then have AI tools, but now you can do it locally. So let's say you're a Boeing or a Lockheed, you can't send your designs through Claude, but now you have the ability to make a tool that's local to your organization that can really be this knowledge store. And the dream, and this is the other reference of what I've always wanted was not the traditional PDM or a PLM tool, which historically they do the things they're supposed to. You put your designs in and you can find your bombs, but let's say you're a new person in a company, you want to find out, well, what parts are using an A to D converter? The UIs are not what I would call friendly for saying, what parts do we use? Are they good? Did we have problems with them? But what if you just said, hey Claude, what audio A to Ds have we used? What's in production? And can you look through all of our Discord chats and what are people complaining about, right? That to me is what I want the PDM. And imagine your company, you could have your little box ingesting all your Altium, all your pull requests, your emails, to really get the context of your designs. So when you go to do a new design, your library isn't that symbol. Your library is all the schematics and that knowledge. You say, hey, we're going to build a new, guitar amp. We want to pull data from all these things. Get me the schematics and get me all the things we learned. That's the value to me of like design reuse. And this was the one of the pieces that kind of is what's needed to pull it together.
Yeah, there. I know that there is at least one AI startup, and I met with the folks there. I forget if it was PCB East last year or PCB West, one of those two shows, that are trying to do this kind of thing where they kind of put together these reuse capabilities. I think you're thinking much bigger, which is getting all of this information out at really massive scale if you want to, and then into some kind of bespoke management system, or maybe even one of the existing management systems, and speeding up design reuse that way rather than just having to chat with an LLM each time.
Think about it from I'm gonna pose this as, imagine if this existed.
Yeah.
So there's two scenarios. Let's say you're a design engineer at a company. You always want to be pulling from your own company's designs of known work, things that have been produced, because you have like provenance.
I do that too, and I know a lot of engineers that do that too, because why do they want to continuously reinvent the wheel? Like if you've got a good power converter for whatever, why are you going to continuously reinvent it? Just pull the known good circuit, and if you got to cost optimize, worry about it later.
Oh, yeah. And so that's like one side, and
right.
That's not too terrible to do, but it is hard when you're still learning a system that all of the data around that data is hard to find, of like, the pain and suffering. But then there's another side of, you're doing a new design. You might start there, but maybe what you have doesn't fit. You maybe need a new DC to DC. So everyone has a different way. You might sometimes I just go to DigiKey and I use their parametric, right? And then you say, oh, I found a TI one. Let me find the EVK. And then you might spend a day just going through 100 options. What if the PDM system had tens of thousands of every known reference design on the planet from all the major producers, so you could ask that LLM that question, and it brings up in the viewer the TI EVK or the Renesas EVK? Because the challenging part of using like a public knowledge corpus is that you can use a lot of open source stuff, and there is good stuff in there. But from the professional side, what you want to know is, has this been produced? And I just know with my work with NXP, when they make a dev board, it goes through UL, FCC, and they make at least 20,000 of them. So that tells me, well, they made at least 20,000 of them, so I got something. And so I think that is the kind of knowledge base. If you could have a system that had that, so you're not spending days scouring the internet for EVKs and is it Diodes Inc. or are we looking at OnSem? Like, I just want one place to ask that can blend my stuff with the rest of the world, and then say, oh yeah, here's the schematic symbol. But we don't give you a symbol, we'll give you the whole thing, right? And you just like, drop it in. To me, the vision is that, because that's what I want the AI to do, because I think some of the apprehension of like taking jobs or replacing function, it's like, I enjoy PCB, but the thing I really want to be doing is the thing that the PCB does for me. It's like, I want to end this guitar, right? I want to be building that stuff. I don't want to be searching DigiKey all day, right? And so I just want tools to take out all this stuff like that is necessary, like, but it's not what I want to be doing. And so, that's kind of like the broad vision. And I've been just working on this, and I keep throwing it out, and some people find it interesting. So
I can say that there was just recently a video dropped by some folks at Octopart, looking at the new Octopart Discover tool, which is actually looking at doing some of the things you described, but I don't know the full capability set yet. So hopefully those guys over at on the Octopart team will respond to my invitation to come onto the podcast and discuss some of that stuff.
As you just saw, you're going to know, and anyone who follows me, I have a couple different names I use for things. You saw Altium Cruncher. The cruncher is
Right.
my way of saying that's a utility that takes data and like grinds it up.
Right.
Then I have monkeys. Monkeys go and get me things. Well, I just built Supply Chain Monkey is the thing that goes and gets me my stuff to feed into the cruncher that grinds it up. So, but say Eli's building Supply Chain Monkey, so you better get on top of it to like see what he's doing. So, because that's part of it too. It's like not only do you got to find the design, right? You got to tie it in the supply chain. Is it procurable? Like,
Sure.
and then the last piece, and this is what I'm spending a lot of time on right now, is that the visuals and a lot of the stuff's done, is that about, I'll say 40% of the EVKs, and I'll say the high quality reference designs are Altium. Another 40% are Cadence, right? Almost always, or it's usually either like it's OrCAD for the schematic and Allegro. And that's about 80 to 90% between the two. And the rest are just, whatever. But if you have those two and can get them into the knowledge store, like, and be able to translate them to whatever the user's using, like, I think there's huge value there.
Yeah.
Because like NXP, I can never get them to switch to Altium. They use Cadence, but there's just all their new applications processors. You get Allegro and OrCAD files. You want to use them, but you want to convert, right? But it's still really good data, right? And all there's, or if you go to TI is all, for example, Altium or Renesas. So the knowledge store is really about getting all this stuff together so we can not be suffering so much.
For sure.
I'm going to build things. I also kind of throw this out, like including any Altium people, is I build it mostly just as an experiment to say, I think if you did this, there's a lot of value. Get your programmers on this. Like there's obviously the, the business side of it, but a lot of time, what I like about open source is that people like me can be playing on some fringes to do experiments to see, is this valuable or is this valuable? Where a big company just might not, because they're focused on, certain things. So I just spend my time fooling around to see what sticks and what takes pain out of my life. So
yeah, that's one of the great things about the open source folks is you never know who's going to come up with something really interesting. And yeah, this definitely fits that bill.
With the theming, like Altium, what you saw was Altium Cruncher was like the tool, but Altium Monkey is actually the library that drives all that. Like I've been, I'm between trying to actually make money and like get real work done. I've been trying to get that so it can be open sourced and nice and clean, but that is coming. And like, there's been a few people like banging at my door saying, when do I get it? And I keep saying soon, right? It's just, and it's, I'm trying to get it to enough where it's usable, where it's not anything I try to put out there. I try to make sure it's not junk, right? It's usable in some form that, has some value. But, after that, there's another one called Cadence Cruncher and Cadence Monkey. And like, I have one called KeyCAD Cruncher and KeyCAD Monkey. Like but it's all blending to the same fundamental things. I want a common, nexus of design data.
I really see the value in that for like the engineering firms that have a lot of, design reuse that they need to do, but they probably have it in different formats. Obviously if you're like a contract engineering firm, right? I mean, like, with what I do, like, 90% or 80%, some really high number, of course, is in Altium. But, every so often there's that one project that comes along in a different format. And, you just can't say no because it's interesting and you do it. But there's some IP there that you can reuse, possibly in Altium.
Or it's just, you just want to take a chunk of it and it's just a reality that you have to deal with. And
yeah. We all got bills to pay.
And you certainly too. Like, and I mean, I've used Altium. There's a lot of things. I mean, I publicly admonish like Altium for certain things, but I love it too because I've used it all my life. And there's things that Altium has done that no one else has in a space. And like, but I do like the fact that there's a couple players and people are trying things, and like circuit board designers kind of get the benefit of it. But for the 3D thing with Altium I put it on them. They're the ones that drove the industry to be using step files and models, and I can't imagine the world without that. Like it was terrible before.
Yeah, and there's so much value being able to like go through and do like walkthroughs, like for a customer, let's say, right? Like this is what your board's going to look like. Like they love that. You know what I mean? You didn't even have to go into SolidWorks or anything. And there's so much value in being able to, do the 3D checking for like collisions, that kind of stuff. I mean, there's all sorts of little stuff with what we do on YouTube. I mean, we've shown umpteen number of 3D visualizations, just so people can really get and get a feel for what a design looks like.
I certainly use it very early on. It's the selling the dream of like, I did this actually a client literally this morning. We're looking at making this big rack with edge cards, and we're just trying to figure out the mechanical part. And so I did enough that, hey, here's what it is, and here's kind of what it looks like. There's no circuitry in here yet that does anything, but this gets you close enough. But he didn't have to spin up his mechanical engineer in SolidWorks, and I could just give him something pretty quick. But it is leading me to the other dream, that I've had when you talk about footprints. And I've spoke with some other colleagues about this, of like, why it's always such a pain in, with sharing libraries and even using AI to make it. And I'm convinced now that and I wish I could get every semiconductor manufacturer on board to do this, is that, when NXP makes a part, they obviously have like the wafer, it goes through a packaging process. They have a full mechanical specification of that package long before that IC is done. I mean, to every nook and cranny of that package, I know it exists. That data should be to me that the library should start with that 3D model to which everything else is derived. So, like, for example, I want to bring in the 3D model, have it create the footprint to that model, because those pin shapes, every formula in the IPC spec is a formula based upon that pin shape. And if you had all that data, to me, that's like the ultimate embodiment. Like Renesas has this chip and this QFP. Well, there's an intelligent 3D format that has the pin names, pin numbers, geometries, does courtyards and everything, just blows out of it. And that way you're not like looking at a PDF and like, to me, that just is so wrong that we're still doing that, it's not like an electronic format the whole way.
Well, hey, maybe you can create the format and it'll catch on. We can all
you
hope,
might actually be seeing it, because that I say that somewhat, that it's already being worked on and the format already exists, that has all the data to do it. It just needs some tools to kind of connect the pin data to that 3D model and then to the IPC spec. Once you have those three, it's actually not a hard problem. It's just more of identifying what is the standard that's already there, and then how do you connect the pieces. So, and I think that would take a lot of angst out of just that whole process, because you have provenance to a manufacturer's specification on that package, not their drawing, not the handwritten thing, the actual electronic data. And so, next to having in your hand, it's probably the best thing.
Well, that's a really awesome look at what's coming next. So I think you preempted my question about that, but I'm really eager to see all of that stuff coming out. So I would encourage anyone who is listening to head over to YouTube and follow this guy, Eli Hughes, to see all that stuff when it comes out.
Yeah, and random stuff on LinkedIn that I just throw out there and see if it sticks, and kind of go from there.
Well, Eli, we're getting up here on time, but I want to thank you so much for coming on and doing this and showing such cool demos and talking about, what's really possible with some of these open source tools. I'm really hoping that we see some of this get incorporated into the commercial software, and I know the folks at Altium pay attention to these discussions. So,
there we go.
Fingers crossed. We'll see.
Yeah, I'm always willing to talk. I talk for free, so
there we go. We're doing it right now, right? Awesome. Thank you so much, and I'm sure we'll talk again soon.
All right. See you.